Hi everyone, in this video we are going to see about the single stack operation of variable reluctance stepper motor. The stepper motor are basically three types: variable reluctance, permanent magnet and hybrid stepper motor. In variable reluctance, it is classified into single stack operation and multi-stack operation. Here in this video we are going to see about single stack operation of variable reluctance stepper motor. This is the stepper motor which has six number of stator poles with four number of rotor poles. The poles will always be in even numbers. The windings A dash is connected with the switch S1, correspondingly B dash with S2, C dash with S3, and it is connected to the supply. The principle of operation, which has different modes, that is, first one is one phase on mode, and second two phase on mode, half step mode and micro stepping. The first one is one phase on mode. The name indicates that one phase is on at a time. Here in first diagram, S1 is on. So S1 is on means A and A dash will get energized. So the rotor is aligned to the position to A and A dash. The angle represents as 0 degree. The rotor 1 and 3, that is rotor position 1 and 3 is aligned to A dash. Next we will turn on S2. S1 is off and we are turning in S2 on. So S1 is off means the A will get de-energized and the B will get energized. In the diagram C, it shows that B and B dash will get energized. So the rotor is aligned to the position corresponding to the winding, that is rotor position 2 and 4. So the angle, it varies the angle from 0 to 30 degree. The rotor is rotates in counterclockwise direction. And again we will turn on S3. So C and C dash will get energized. Further 30 degree, the rotor will move and align to the position of C dash with rotor poles numbers 1 and 3, and it keeps on rotating with again the S1 is turned on and again further 30 degree. So one phase on mode is with 4 number of rotor poles is suitable for 30 degree rotation. The tabulation is shows for both counterclockwise rotation and also the clockwise rotation. Here the table, that is counterclockwise table, represents S1 is on, so 0 degree, S2 is on 30 degree, S3 is on further 30, that is 60 degree, again S1 90. And again in this position for clockwise direction, first we have to turn on S1 0 degree, S3 30 degree and S2 60 degree. So the rotor will rotate in clockwise direction. Two phase on mode, as here also the name indicates, two phase will be on at a time, that is either AB or BC or CA. First we will see in the figure number A and B are get energized. If A and B are get energized, the rotor will not be able to align to the single position, that is it is tilting between the position windings A and B. So the rotor is 15 degree from the center position, and next we will get we are energizing the winding B and C. So the rotor moves further 30 degree and aligned to the center of the position between B and C. So first it rotates 15 degree and from second times onwards it starts rotating further 30 degree. Likewise we can turn on CA and again AB and BC, and likewise it moves on. Here also the table represents the counterclockwise rotation and also the clockwise rotation. In that we'll see AB is get energized, so 15 degree, and then BC further 30 degree, 45 degree. In clockwise rotation, first we have to energize the winding A and C, that is S1 and S3 15 degree and BC 45 degree and AB 75 degree. So for the rotation of 15, 45, 75, likewise we can turn on the machine with two phase on mode. Half step mode, it is a combination of one step mode and on two phase on mode. That is, once we have to turn on the single winding and parallelly two windings and single winding and two windings. That is, first we are energizing the winding A, second AB and B and BC. Likewise, we will energize. So the rotor will rotates like first A 0 degree, AB 15 degree, B further 15 degree. So when we want to rotate the motor with the rotation angle of 15 degree, we can use this half step mode of operation. And the last one is micro stepping. Micro stepping is a way of moving the stator flux of the stepper motor more smoothly than in full or half step drive modes. This results in less vibration and makes noiseless stepping possible down to 0 Hz. It also makes smaller step angles and better positioning possible. For example, a stepper motor with a 1.8 degree step angle will make 200 steps for every revolution of the motor, that is 360 divided by 1.8. This discrete motion means the motor's rotation isn't perfectly smooth, and slower the rotation, the less smooth it is due to the relatively large step size. One way to elevate this lack of smoothness at low speeds is to reduce the size of the motor step. This is where the microstepping comes in. Microstepping control divides each full step into smaller steps to help smooth out of motor rotation, especially at low speeds. For example, 1.8 degree step can be divided into 256 times, providing a step angle of 0.007 degrees, or it is 51,200 microsteps revolution. Microsteps is achieved by using pulse width modulation voltage to control current to the motor windings. Thank you.